Hello. I think all can hear now. Yes. I just asking you like anybody want to introduce yourself? Just say your name, what are you doing? Where are you from? Like that. Here you are going to see my introduction, what I am doing. That are all in the slides, but just wanted to get you. Sorry? Oh, still you're not audible. Huh? No. Okay. You.
Hi all, myself Kalaivanan. I'm heading the IT division of Schnell Energy Equipments, an IoT-based smart city projects company. And we are our technology division is called Sapien Flex. I'm handling that.
Great. Any other?
Hi, this is Arni, and I have come along with my friends to attend this event. We are from CIT, and we are studying artificial intelligence and machine learning.
Great.
Hi, I'm Prasanna. I'm a DevOps freelancer. Recently moved to Coimbatore.
So, hi, myself Ritik. So I'm a senior full stack developer, like in Info Private Limited from Chennai. So I recently get interested in AI. Like, let's see how I explore that.
Hi, I'm Rohit Pranav. I'm a sophomore CSC student at Dr. NG Tech, and I'm a freelance blockchain developer.
I think I got more than enough introductions. Okay, let's slightly get started into. Okay, today we are all here to build your multilingual support bot with RAG, right? To know the agenda, right? What are we going to see in the slides? In this hands-on workshop. The agenda will be the three main things. Using the multilingual and RAG support, we are going to build a support bot. That is the main agenda over here. To get a teaser over or a trailer like what we are going to in the workshop, right? It is none other than like you will be having some queries which will be getting into some numbers. That numbers will be getting searched in a database. On that from the database, we will receive some again numbers. From that, if we want to get a meaningful insights, you will get some. I know you will not getting understand, but just a trailer. We will see, we will deep dive into each and every concepts, how it is getting converted, how it is getting searched, where we are storing it, everything we'll search. Okay, let me introduce myself. I'm Srijan Rajendran, working as an AI developer, engineer in ThoughtWorks. That's a simple introduction of me. That's enough, I think so. Let's go to the next. You just get into this, Google Docs, so that if I share something, I will just paste it over the Google Docs. You can get it. If you have any laptops over here, you can just turn on and get started. Because it is like an hands-on, I have some practical things to for you. You can build a RAG application. So, I think you will be getting inside this, I think so. I will pretty soon use it. Yes. Okay, let's get started with the multilingual part. Let's consider this hands-on workshop as a two major session. Major session as a RAG, and other thing is multilingual support. Okay, let's get started. Okay, multilingual. When it comes to multilingual, right? I'm trying to, show you a application or a software developed by an Indian government named Bhashini, which will be able to convert Indic languages, overall Indic languages, like any language from in India, like Hindi, Punjabi, Sanskrit, Tamil, English, anything it could be able to translate. Maybe it could able to translate, and also if you give us text over there, and it will be converting into translated audio also. This is available as application for Android and iOS also. And also API services is also available for this. Today we are going to see about the API service, how can we access, how can we get the API and how can we utilize this Bhashini app, okay? Maybe here we could see that the input of this for this Bhashini API will be like source language will be the language which you give as an input, and the target language is the language which you expect to be coming out from the Bhashini, and the text is the text what you pass inside it, so that it will be getting translated. I'll paste the link in the Google Docs. You can access that also. Using this, we could just get started and create a API over there. And let's see. You can just start creating the account over here, create an account, and start filling your details, and let's get inside it. Now we are doing this to get only the API access from Bhashini so that we will be easily able to translate. Maybe this will be used for your RAG application also. If the user asking a query in Indic languages, you will be able to understand and translate from, I mean, to the, maybe the probably all the LLMs will be responding in English because they know that well, English have been a large data set for them. So if we want to convert the output to any other Indic languages using this Bhashini, we could able to do that. Is the major plus point of this Bhashini we are using. And this is also this is actually an AI model which is used to translate one language to another. It is also an open source models are available in Hugging Face, which is released by Indian governments already. We know. Okay, I think most of the people maybe let's get doing it. Okay, once you see that, you could see my profile, right? You could click over there. Maybe I will revoke this key. Okay. You could see your user ID over here. This is also actually more needed. And you can see a button like generate API key, right? We can just click, create a drag. Okay, we should not have any. I've already created. I mean, the name is there. We are not allowed any special characters over there. Please check into it. Under caps letters also not allowed, I think so. Please check. Okay, once we got the apps API key, this is also needed for us. And then at the end, we will also be generating another inference API key. We needed 3 API keys for this for this to generate Bhashini's translation from one app to another. Okay. I think most of you got the API keys, 3 API keys. I think mostly it is visible now. Okay. Currently, you can just open your Visual Studio Code and start. It is like executing it. Basically, this is a Python library, a Bhashini translator, which we use to API key to get translate over there. And .env is something like you will store the env keys in, keys all in the env file, so that we can load it anytime. And once it is getting loaded, we can access it. That is the main use of these things. Maybe just start executing it, and I will also meanwhile copy paste this in docs also so that you can easily access it. Okay. I think after importing the libraries, we can just copy paste the API keys over there and make it to run. I'll just start doing the API key part completion and storing it as an env file. Let's do that actually. Okay. First, we need to copy out the user ID, then paste in the area of user ID. Please check the capital and the small, uppercase and lowercase while you entering the API key names actually here. That is very important. You will see a API key should be the second API key, which should be pasted over there. Next comes the last and final API key, the inference API key. We can see your inference API key value. Need to copy and paste it over here. Once we are done by running this code will be creating .env file and .env file and saving all your API keys in .env file and loading the .env file. To load this load underscore .env only, we are importing .env library actually. Once this is done, we will see an output of true, which these API keys are saved in the .env file. And if you need to check what are, check the env file, what's inside the env file, we can just click on cat.env. We will see the API keys over here. And these are the languages supported in Bhashini, like Assami, Bengali, and more languages, Malayalam, Tamil, English, Sanskrit. There are more languages. Each and every language will be having a source language code actually. Like I will show you in meantime. This is a function which you will be able to access the Bhashini underscore translate. Basically, this is the exact code. Inside Bhashini, you need to pass the source and target language. Once the Bhashini is ready, Bhashini.translate, and if we pass out the text right, we could get the translated text as an output over here. Maybe I will. Basically, I'm saying the source language as English and setting the target language as Hindi. Hindi has a value of HI over here. For each and every language, it is has an unique key. So there, like Tamil will be having TA, and Sanskrit will be having SA, I guess SA. And we need to pass the text also here. You could see the output over here. This is the overall picture of Bhashini translate. From any language to even from Hindi to English also we could able to change actually. Is this clear? Where are you all? Have you just tried it out? If you have any problem in running the cat.env is not cat is not recognized error erases, just leave the cat. Cat is nothing but to see what's inside the env file. None other than that. You can also click on .env file in your folder structure, and also you can see what's inside the .env. Else cat is not that much needed actually. And also don't use square brackets over here while starting the API keys. Maybe I have entered here, I will just remove also. You can just copy paste the API keys alone is enough. No need of square brackets. Okay, let's next go into the main topic of our hands-on. Retrieval augmented generation, RAG. Do anybody know what's RAG before this workshop? Do you have any idea on RAG? What can a RAG do? Just hand raising is enough. I am not going to ask, tell me about RAG. For sure. You have some idea, okay. Maybe a very few audience. Let's start from what to say. AI or artificial intelligence is a technology which is used to or made to mimic what humans are doing. Basically, if we are able to identify something or do something, that AI can also do the same thing. That is a main aim of creating AI. If we are able to detect what is a chair, what is a laptop, what is a table, then AI should also be able to do AI should also able to detect what is a chair. Is there a chair? Is it a laptop or a table? That is all known as the actually narrow AI. Narrow AI is nothing but a single task performer. Like AI which is specifically used for detecting objects, or like detecting a particular object, table or a laptop or a chair. It is like will be doing only one work at a time. But when it comes to generative AI, right now, current state is multitask performer. Basically, if you give a input prompt to an generative AI, it will be able to do many things. Like if we give a long article, it will, first of all, it is able to understand and ask. If we ask it to generate questions, right, it will able to generate you questions or summarize the articles. A single model can perform multiple tasks. That is known as now generative AI, or which is different from a narrow AI. These much days we were all training narrow, I mean deep learning models or machine learning models or AI, which is these are all narrow AI, which will be able to perform a single task. At the end, the output result will be binary or multiple, like yes or no will be something, I mean some output, or a range of numbers from 0 to 100 will be an output. But when it comes to generative AI, it is not like that. It is, as I said, it is a multitask performer, which will be able to understand or create or think. Maybe it is like replicating like thinking. Actually, it is not thinking, but it is replicating like the human have some creativity, right? So, like that, it also tries to replicate the creativity. Okay. After that, inside the generative AI, right, we have LLM, large language models, which is something, its core aim is to predict the next word. It is also called as a next word predictor. If we give some prompt or an input, it will able to understand the input and give a output of probably this word will be the next word of this sentence. That is the main aim of the LLM actually. Like we can see Shanghai is the city, I mean, from until in is the input of the user actually. After that, China is the next token which is predicted by the LLM. These are all trying to predict the next word by massive context what we gave in training data actually. Training data is something I like, internet scale data, it's that much huge, so that you will be able to easily identify what will be the next word of the input what we have been given over here. Basically, this is an LLM, next word predictor. You got it right? Okay. You are what you eat. It is nothing but like what data you give to a model, the model will be able to understand or predict according, or what is inside the training data, it will be able to do. Other than that, when it comes to, if you are asking something unrelated or non-training data questions to the LLM, it will be hallucinating, or it will not be giving any exact answer or the factual answer what is needed. For an example, if we are training the whole LLM with an English training data set, right? And if we accept the LLM to give an output from, I mean, in a French or Hindi, right? It will not be able to do, because it has seen only the data of English, which is its training data. So we cannot accept an LLM to give the data which it is not trained actually. That is a main point of an LLM. For that, if we need to do that task also, right, then comes the fine tuning part. It is all creating a data set, or then comes the training a model kind of thing. But it is a huge expense. That aspects and all we need to consider when it comes to an LLM. Okay. Yeah. We are coming to RAG. We felt one problem in LLM, right? It could be able to understand or give answers to us only with the training data what it has been consumed already. But when it comes to RAG, right, we have an example like, if you want what is the return policy of a company XYZ. Maybe it is not in a company actually present or a familiar company, maybe a new company getting started today, but it will not be able to understand, or it will have been not seen the data of the return policy of that company XYZ. I mean XYZ, any company it may be. Maybe it is started today or yesterday, or which is going to be started. But this cannot be actually answered by the LLM. But using RAG, right, if we have the privacy policy as a PDF or a text file or any file source of input, if I am the company owner of the XYZ company, and I want to create a chatbot for my clients or customers who is visiting my website, and if I have the privacy policy and the return policy of my company, right, I could be able to create a RAG system over the PDFs or the source of input what I have, and create a create a chatbot with that actually. The using that PDF to question answering method, right? That actually RAG is more involved on that concepts. We will detailedly see how we can convert the PDFs or store the PDFs, or that and all we will be able to see. But as of now, we need to know that if the user is having a text, media source, right, like a PDF text, anything, easily the LLM can be able to answer the questions from us to the PDF using this RAG system. Basically, a question answering session within the PDF. That is RAG. Okay, right? Why we need RAG, right? That is a major question. That is a major question. The basic statement of RAG is the questions which all not can be, I mean, which all not be answered by in LLMs, normal base trained LLMs, right? That questions can also be answered by with this RAG system. We are just adding a RAG to the, I mean, base LLM. That is, RAG is something like a feature, giving an extra feature to the LLM so that it could be answered to the any data present over here. I mean, the input data at least. Actually, this improves the LLM's accuracy. It is like we are not actually fine-tuning or training the model again to improve the accuracy. As a user point of view, okay, the LLM is giving a right answer or wrong answer is the user's point of view. So from that point of view, if we see it is improving the LLM's accuracy. Okay, right? By how it is getting improved, I mean, increasing the accuracy, right? It is by leveraging the external data source what is given by the companies. It gets input as company's PDF or any external data sources and try to process that. And after processing it, it will be able to answer any queries given by a customers. We can also pass a domain specific related to the company so that it is getting boosted. And it is very easy to implement than fine tuning. Maybe if I give an X scale rating, right, it will be 100x or at least a 50 or 70x way more easier than fine tuning LLM. For fine tuning LLM, we need to start with particular very neat and clear cut data first of all. Then we need to prepare the data format for the LLM. Then we need to fine tune the LLM. That is all very huge task and cost. It is not also cost effective. When it comes to RAG, right, you can easily implement this RAG system. I have added a point, improves trust and transparency. When it comes to LLM itself, it is like a probabilistic model, which will be not, maybe it is generating the data. It may not be an accurate, it may hallucinate. It may say the false data also. But here I have added improves trust and transparency, right? That is because of if you are giving an input data source, from that data source it is answering, right? Maybe after getting the answer, we can also check the area where from which it has been retrieved the answers, like in which line from the PDF it has answered also. Nowadays we are seeing in Gemini, right, where from which all websites it has been saying the answer. Like that also we are able to do with the PDFs or text files what we upload. Okay, right. This is the simple RAG architecture. Now I'll be explaining this, but you may have some questions. What is this? What is this? What is this? Eventually in the slides, I will try to explain. If you have any questions, at last I will be able to answer. Okay. Okay. From when it comes to RAG architecture, right, it is nothing but we need to upload documents or web pages, basically crawled from web pages and converting it as text files. And once the text file is processed, I mean, we have a text data source, right? We are going to convert into chunks. We will see what is chunk and why are we converting into chunks and all we will be seeing. But once the chunk is ready, right? A chunk is nothing but like it has a long book. If we are getting the data source, text data as a long book, right? We cannot directly push it into vector database or database. We need to actually split it into some like, if we have a story like chapter wise or paragraph wise is known as, I mean, basically a chunk. From that, we are just converting into embeddings. Embeddings are none other than, like I showed in the initial slides, are converting text into numbers. Why we are converting that into numbers is basically it is like an index of the text so that it will be more easier for us to search. Okay, after converting the embeddings, it is like an index value. We will be storing it as in a vector DB, where it will be having both the embedding on the chunk as stored. This is the actually background part which is done from document retrieval and converting into chunks and embeddings and storing it in vector DB is a background process done by a developer point of view. And when it comes to user point of view, right? User point of view will be asking a question: how many parameters are there in group 3? It is developed by Twitter, I think so. That is a query over here. That query will be again in converting into an embeddings, which is like an index value, where the vector database will be trying to match these both embeddings, which embeddings are more similar will be getting retrieved from this vector database actually. Why are we converting this embeddings is to search between the answer which is present in the database already and the query. That is why embedding is present over here. So once we pass this embedding, we will be getting the similar text which is already present. Like this is after announcing a XA. This is the output from the vector database. It is like a paragraph which is already stored from this chunks. Okay, right? Once this context and the query is now ready, we will be passing that into a prompt template. Prompt template will be having like we are chatting with LLMs, right? You are a helpful assistant. You need to answer to the query given by the user with this context. If you mention like that, this is a simple prompt template I am mentioning. With this templates, right? If you pass it to an LLM may be able to identify the question, and we have a large text, I mean, which has the answer actually inside that. We will, if you pass this both inside the LLM, then LLM will be able to answer. Group 0 has the prototype mentioned, has the 33 billion parameters, actually the user's question. User will be expecting the 33 billion parameters is the exact answer it is needed. But if it is not trained in the LLM, right, because it is, these models are getting introduced very recently, but it may not be already trained using the trained in the LLM, because we itself say some questions, my knowledge limitation is up to only 2021 or 2023. From on that cases and all, we can use this so that it has a large answer which is passed from the vector database, so that it could be able to answer from this question can be answered from this context. The LLM can understand, to LLM understand that I have the answer within this. You need to answer the user's question with this context, right? That is done by the LLM over here, so that it will be able to give out the expected answer by the user. Okay. Let's see how can we implement that at all. First point is the main background part which I have mentioned, storing the data, which I have just shown here, right? Collecting the documents, splitting into chunks, converting into embeddings, then embeddings are stored in vector. This is actually storing the data process, which is the background part. Okay. Basically, as I already said, loading the data can be any type of file, code or PDF or a text file. Maybe sometimes embeddings are, I mean, storing like this and using embeddings can also be done for images and videos or also. But today we are going to see about the text files alone. But Google, all your Google searches are similar. If we just click a photo in Google Lenses and it will suggest more related photos, right? That are all done by these embeddings. The photos are converted into embeddings, and it will try to match with another embedding which is present already, so that it will be able to retrieve the similar photos from the data from their sources actually. That is happening in Google searches also. Then we will be splitting into chunks. Basically, why do we want to split it into chunks, right? If we are storing the whole extracted text in one column of a row itself, let's consider as an SQL, right? In SQL, we will be storing each and every data in each and every row. If we are storing all the data in a single row and try to retrieve a single row by putting some query, right, that is not meaningful at all. Because if you try to retrieve a single, single data and which is stored in a bulk type, right, that is not at all going to give us meaning. So only we are just trying to split it into each and everything, because one topic itself will be in a single paragraph that can be stored as a separate thing, and next topic will be stored in the separate paragraph. If the user asking a question in the topic A, then it will only retrieve the topic A's answers. It will not going to retrieve the topic B's answer, because we are storing in separate chunks. That is the main reason we are storing it as chunks. And embedding is already I mentioned. It is like a index for the the data what we pass as chunk. Because these chunks cannot, like, it is not an English search, like if we search a word, is the word is present in that. It is not like that. It is like a similarity search done between two vectors actually. We can see the vectors over here, right? That vectors are will be matched with the question vectors, so that it will be able to easily retrieve the documents which is more similar to the question. That is why embedding is also done over here. Then we will be storing both this chunk text file and the embeddings in the vector store. Basically, then we will pass the question to the vector store so that it will be retrieving the text file what is needed. That is done here. We will see each and every file as an individual. We have all discussed this actually already, but still data source can be like any type of file, like videos or images or a text file or Excel file. But here we are currently seeing about today, we are seeing about the text files and the PDF files. And when it comes to chunking, I already answered these questions. Why not? Why not without chunking? Without chunking, if we pass means it is nothing meaningful. Every data will be stored in a single row. If we try to retrieve, if we put any questions, all the data will be, giving back as an answer. If we pass it to an LLM also, it will not be able to fit in the context length also. So that the full book, if we giving as an input to LLM, ChatGPT or anything, will be saying like, sorry, context limit exceeded. Try to shorten your prompt. So avoid those all things. We are using chunking. Then why chunking also I already mentioned. If the question is related to the topic A, then topic A is stored in a separate chunk, right? We can retrieve only the only a single chunk, which will be a memory efficient thing. Storing the data is also more easier. Handling the data will be still more easier. Yes, I already mentioned embeddings. Embeddings are nothing but the index of the chunk actually. Each and every chunk will be converted into embeddings, and the chunk and the embeddings will be actually stored. And the embeddings will be stored actually. As I already mentioned, what embedding capture? Embedding will be capturing the semantic meaning of the text actually. So that only if the user is asking, if I am storing what is Python, right? I mean, the answer of Python, what is Python will be having the who invented Python also. So if the user is asking who invented Python, right? The word Python invented will be common in both the answer slide, answer slide also, in the question area also. So from that matching, it will be retrieving the resources back, and we pass that to an LLM so that it will be able to answer who invented the Python, right? Some of the common models are TF, IDF, and word to vec. Word to vec is something like word to vector. Vector is nothing but the numbers, floating points within which we are passing. Okay, I think so. There are some other nowadays. These are very basic model. Nowadays there are high-level models also, domain-specific models also. If we are trying to build a RAG system for a medical domain or a healthcare domain, specific to that domain, we have embedding models. Or if we are focusing on any domain-related things, that type of embeddings will be easy to convert into numbers. Maybe it will be seeing more domain-specific names, right? So that it will be easy to find the semantic meaning from the text what we have passed. Okay. Okay, when it comes to storing, right, we are not using the traditional database what we use, SQL or NoSQL. It is something like known as a vector database. Vector database are a new concept which is currently in the booming state because of this LLMs. LLM promoted the RAG concepts, and the RAG is promoting the vector databases. This is currently this vector database. All top database companies are trying to adopt this vector databases. Basically, it will be containing the vector data which we have created from the embedding slide. And that from that slide, we will be able to store the vector and the chunk we passed to embed the actually. We will see that example also. This is the main purpose of vector databases. And for that, from the fast retrieval, what is this fast retrieval means is, again, your question will be in another vector. So to find a cosine similarity between two vectors, right, it will be more easier for when it comes to computational or searching also. Basically, this retrieval from the vector database happens only through the cosine similarity or any distance. Basically, it is finding the distance between the 2 points. If the two, we should consider this all, this full vector as a single point actually in a n-dimensional space. And your question will also be giving us an vectors. So if we plot in a graph, right, how much distance between the 2 points are way more matters here actually. So if it will retrieve the top similar, I mean nearby data points, and that inside that data points will be containing the, containing the data which is stored as chunk, which I already mentioned. Okay, let's move to the next. Okay, now let's see the visual implementation, right? Okay, let's start with the text from document. Text from document is nothing but the text which we have now currently retrieved from a PDF file, or even it can be a text file also. Even some images which contains text also, we retrieve the text. We will be having that as a text file, which is which is exactly a long paragraph, or it may be a story which will be hundreds of pages also. It may be a number of size, but what we will do is we will split it into chunks. As I said, split it into chunks means like the first line here, we have set it here like the first line may be in the first chunk, the second line may be in the second chunk, and the third line will be in the third chunk. Because if somebody is asking some question related to this question, I mean, this alone, RAG is one approach for solving these challenges, right? Which is the best solution for solving these challenges? Like that somebody asks, right? It will only retrieve this chunk. If we retrieve, I mean, if we pass this chunk on the question to the LLM, right, it will be easily able to answer RAG is the exact word what they are needing, so that it will be more useful. This is why chunk is actually needed. Once we are completing this chunks, right, after converting each and every line, each and every line may be like it is currently we are using it as line, but it may in day-to-day life we will be setting as a character limit. After completing the 1000 characters, right, it will chunk. Then the second chunks will be getting started with. Then it reaches the 1000th character, it will get stopped. It will be abruptly stopping. Then after that, we will convert that into embeddings actually. Each and every chunk will be converted into embeddings. That embeddings are, I already mentioned, it is the index of this chunk actually. We will not search, if we give a question to the RAG system or LLM, like the keyword LLM has an over enthusiastic, it will not search actually this keywords actually. The question also will be converted as a vectors like this, and these both, I mean these all vectors and the question vector will be actually calculated with the cosine similarity or the distance formula. If this chunk is more less, I mean the distance between the two vectors is so smaller, then this chunk will be retrieved and given as the output of the vector database. After creating the embeddings, right, with the chunk what we had, we will be storing in the vector database like this. The embedding will be like the index of the chunk over here. Each and everything will be having a embedding and a chunk. Embedding and the chunk for all the total data we have in the text file will be converted like this with the embedding and the chunk. Okay. Actually, this is the part one which I mentioned. Like in the previous slide we saw, right? Way long back. Yes. As of now, we have completed up to this. From the when it comes to architecture, we have completed up to this. From loading the documents, splitting into chunk, why are we converting into embeddings, how we are storing that into vector databases. This is what we have seen up to this time. Okay. Second part is the retrieving the data from the vector databases. We have now efficiently stored the data what we have in the database. After that, now we need to see how can we, if a user is asking a question, then how can we efficiently retrieve the data? That is the main point. It is something like the user will be asking a question which will be passed to an retrieval engine. This arrow mark is something like, which I mentioned, right? This question will be converted into embeddings. That embedding will be getting searched from the retriever. This is a high level diagram, but we will deep dive into that also. But in this diagram, we are mentioning that the question will be passed to a retriever engine. That retriever engines will, the retriever engine's answer will also be passed to the prompt. And also the question which is given by the user will also be getting passed through the prompt. Once the prompt is ready, right, I have already set given the example, right? You are a helpful assistant. You are going to answer the user's question. Here is the question, and we will be passing these questions to the prompt, and also the retrieve. And the context is here. This is also the context which is retrieved from the vector database. We will this is a prompt template. This prompt template will be passed to the LLM. Then the LLM will be able to, okay, the user is asking the question. And here, with this the long chunk itself, there will be answer. We need to search and give him the answer. That is the main thing. The LLM need not to know the previous knowledge while it is trained itself. It need not to think by itself, because we are giving, it is like something like, we can say it is an open book test. We have the answer within a long chunk. The question is question by the user is also there. The LLM's duty is to go through the answer and answer. I mean, go through the context and just answer the question given by the user. After it is getting passed to LLM and it gives the answer. That is the overall system. Okay, this is I mean, this is the visual representation I have done. Like if somebody asks what I think of the LLM as an over enthusiastic, right? This is the exact I mean question will be given by the user. That question will be getting converted into embeddings. We can see that this vector will be somewhat similar to this vector. I mean vectors over here, so that it will be calculating the distance between these two vectors actually. We can see over here, right? These two vectors are getting calculated the distance, so that if this vector points and in this vector points are so similar, right? It will be retrieving this answer like this. The vector database will be giving the end result because this vector point is more nearer to the question, so it will be giving to this as an output. Then this answer will be passed to the prompt template, as I said already. Yes. Okay. Okay. Maybe I thought I would complete the whole session on the. Okay. Okay. Maybe if you have any questions, I may also say this again. Also, if you have questions in any part one, I'm ready to answer. Architectural diagram. Okay. Maybe anyone having any questions? Feel free to ask. I will be start explaining again also from the start. Okay. Yes. Okay. 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 Hmm. Yes. Correct. Correct. Yes. This is what you understand is clear. Actually. Embeddings. Correct. Yes. Okay. Maybe what he asking the question is, we are seeing I mean embeddings examples over here, right? Like this vectors, right? Is this how many this dot dot or three dots at the last refers to how many numbers will be there in this vectors? Something or yes, yes. It has a format. It has a format means each and every model is unique in this actually. Some models will have 768 values in a vector, which means it is a 768 dimension. Maybe like some current OpenAI models will be having 1024 values in a vector. In a single vector, there will be like 1024 floating point values. That totally depends on the model how it is getting trained also. So each and every vector, if we pass the length of the text may be one paragraph or 2 paragraph or 5 paragraph, once we pass to an embedding model, right, it will be giving output as the 768 values within the floating point. So that only it is so efficient while when it comes to searching. If we want to search a word in 1 paragraph will be more easier. When it comes to searching a word in a 10 paragraph will be harder. Uh, while I'm saying it as a manually itself, I'm saying. But if we having this embedding values, right, as an index value, right, this will be more easier for vector databases to search the question what we pass. This is why how much big the content may be, it will be able to retrieve the content exactly. I think this hopes answer your questions. Floating points will be there. Yes, pointer to somewhere, exact. The circle will be, the detail will be, yes. Do anyone have any questions or, yes, please. Hmm. Okay. Okay. Hmm. It is actually a very good question. It is not actually compatible. Maybe with the same dimension level, it will be able to, I mean, same dimension level by the same company means it will be maybe compatible, but each and every embedding value from each and every model will be unique actually. If you are embedding a text in model A, right, that output will be different than the models B's output. So that only we are able to compare the benchmarks from the embedding model that are all happening. Each and every time a new version of embedding model releases, it gets even better and better how to optimistically convert the text into numbers. That is actually happening. Uh, Actually, here training is not at all involved. It is just like an input output. It is a function. Into an embedding, yes, sir. So that only people will be sticking on a single company wide, company specific embedding models, so that the company will ensure that their answers will be retrieving more efficiently. After this Google's Gemini era itself, they have changed the embedding model in between actually. First of all, first they were having a different embedding model which is by the Google Palm models. Now after Gemini has introduced, they have introduced Gemini embedding models, but they still support both the embedding models. If your application is built on Palm embeddings, it is supporting, it will be doing all the characteristic what you, when you have built that, it will be expected, work like expected. But if you change the new embedding models, surely you need to change all the text again. Then once you're changing means it is for your efficiency only you're changing. So that is the advantage. And the disadvantage is you need to change the whole text again. I think it will answering. Do anyone have any questions? Have you understood anything? At least anything? I can now understand. You are saying that we are giving a question to LLM. If the embedding model changes, we need to change the prompt. No, that is not required because that prompt will be converted by the new embedding model what you are using. So that it is basically calculating the distance between the 2 points. So both the new embeddings point will be easily matched actually. So prompts, the high level human prompts need not to be changed actually when we change the new embedding model. Okay. Are you able to all can catch up or good, right? Any questions? This is manually, this split is done by, I mean, manual, as I mentioned that we are currently, day-to-day use cases will be like split after 1,000 characters. In program itself, Python program, we will be setting that how much we can split, 1,000 characters or 10 characters, or that is manually set, number is given, manual numbers. Okay, then let's go to the part 2. As I already mentioned, like it is a common embedding models. This is the models. Model. This is also a model, but its input will be a high level text and its output will be a vector. GPT will be answering your question English, right? But this will be answering you in a vector format. So that it is an embedding model. Embedding model. So that embedding can be stored in a vector database. Okay, the second part is the retrieving the data. I have explained this also, I think so. Okay. Okay, I think as of this, can you all understand? I think the part 2 also got completed while we start the Q&A. I think so. Have you understood the second part also? Can I start with the second part again? None other than if we get an embedding model as an output, right, we will be storing it in the vector database. Then again, our questions also will be converted into embedding models. Actually, this is the question embedding, and it will be it will be searched in the vector database. After searching, the vector database output will be like a single. I mean, not a single user-defined number of chunks will be retrieved from the vector databases. Then that will be passed as into the prompt template. Okay, I think still you may be having some questions, but if we are into the hands-on, right, I think that will be cleared also, I think so. Let's start with the LLM, right? As I already mentioned, we need an LLM to do this. Please all try to download this from lmstudio.ai. It is compatible in Mac, Linux, and Windows, all three OSs. You can download this. By what is the advantage of downloading? This is like you can able to run LLMs in your local laptop itself, so that we can implement RAG concept in a local system. This is like without internet or 1 second. By installing this without any internet or any source, we can use the LLM to answer your queries. It is similar like ChatGPT kind of thing, but which runs in a local model. It is a we are going to try out a Llama model, which is a very small model, which is running in your laptop's inference. It can run using CPUs also. It does not primarily need a GPU, but the speed of the inference will be getting deferred. I think I will paste this link also in the Google Docs. So once you have downloaded this, right, we will try to install a small model. You will be in this page, I think so. Just try to search Llama 7B. Are you seeing this page actually? Llama 7B chat. Okay. If you search Llama or Llama 7B anything, you will be able to see this search results actually. From this, you can try to install Llama 2 7B chat GGUF model. That will be mostly in most of the laptops. This will be heading at the first. And from this, we can install this model like Llama 7B Q40 model, which is I have downloaded it. You can see over here, right? Maybe I will paste this name in Google Docs also. Make sure that the file size is around 4 GB. Check to that also. Please try to install this model Llama 2 billion 7. Llama 2 7 billion parameter model with the chat option of Q40. If you have downloaded the model, right, you have here a chat option where you can load the model. Maybe you will be seeing only the model which you have downloaded already. If you can just give a click, maybe it will be asking accept a new system prompt. Just give an accept, and you will be here. You can see the model is getting loaded in your RAM. Most of the system we are using here should be above the level of 4 GB RAM, I think so, because the model file itself around 4 GB. So recommended is around 8 GB plus. And you can chat over the models over here. Like what do you do in ChatGPTs or Gemini? This is the model's output you can send. This actually this is not at all connecting to any of the internet. It is totally running on your local. It is a local inference. The model is loaded in your own laptop's RAM. This answer comes out from your own laptop. You don't need to connect with any internet sources. I think there are some other features in this LM Studio also. Here is a playground feature. This is for multi-agent system. Now we need not to concentrate on this. Local server is the area currently we will be using. This is actually create if we are loading the model over here, right? We can create an endpoint from the model. This is the endpoint. We will be creating a localhost endpoint, the API keys. It is more similar to Open API keys endpoint, where you can use this for local development area. Once your application is totally developed, you can just change the base URL and the API key from the OpenAI's website. So this will be more helpful in development point of view, is running the model in the local itself, so that your data will also will be not sharing to OpenAI also. Then at last comes the models. These are the here you will be seeing only one model. But all the models which you have downloaded will be shown here actually. I think most of the people are downloaded the model. Let's wait 1 or 2 minutes and continue. Okay, I think most எல்லாருமே download பண்ணிருப்பீங்கன்னு நினைக்கிறேன். Okay, let's start. After here, I think now you can see the screen, right? This endpoint access screen, right? You could able to see the endpoint here. This is my own localhost endpoint and the API key ID. Here is the model which you have loaded will be shown for you in your own screen. Once this is ready, we can just move to Visual Studio Code. Okay. And just try out. First of all, we need to install OpenAI for this actually, because this API endpoint version will be most compatible with the OpenAPI's API key, because the same form it will be in the it will be same format. Only the base URL and the API key on the model values will be different to the actual OpenAPI API keys and our local API keys. Initially, we need to install OpenAPI, and then we need to just import it actually. Then use a function to actually load the model over here. And the main thing over here is you need to give the system prompt over here. I have given the system prompt like you are a Q&A chatbot interacting with the real world customers to their questions. Only answer based on the content which is provided, and do not provide your information other than the content. Actually, this is the main. I'm setting a system prompt to the LLM actually over here. Once that is ready, right, I will pass. Then our input will be passed as a pass LLM. I'm passing over here. As like that, you can see here, pass LLM is none other than like question will be first, the user question will be passed here, and the content will be like the information which is retrieved from the vector database, right? As I already mentioned, that will be passed over here. The question will be the user's query, and from the answer which is retrieved from the vector database will be the answer that answers will be passed to this LLM. Once if that is passed, then we can get the answer. Get the expected answer. Here I have also set a temperature is equal to 0.7. This temperature here refers to randomness of the model or the creativity of the model. If we are getting near to zero, it will be less creative, less hallucinating. It will be fixed on its answer. When it is getting near to 1, right, it will be getting more creative, and sometimes it will say the false answer also. It is not an accurate answer, but it will be more creative. Like if you want to write a poem, or that use cases like writing a poem or creating a story, right, then you will be setting the temperature as 1, nearing to 1. If you are answering some questions or factual data we need to get, right, then we need to set the temperature as near to 0 or 0.1, like that. That's the main thing. I'll just paste the code over the node, docs, so that you could install and try out this also. From this, the main aim is to, now we have loaded the model in our LM Studio, so that using the Python code itself, we can send the prompt and execute from our local inference itself. I think this is a simple RAG which I have built. Actually, this will be happening as a RAG, what I mentioned. Here we have asked a question, what is the population of Delhi? And gave a lot of information about Delhi, and we have also included the Delhi's population also. Once this is the, actually, according to the LLM function which I have defined as, first you will be passing the question, then again next will be the content that will be passed as a pass LLM over here, so that it will get the question of the user and also content retrieved from vector database. Just for reference, I have added the content by myself. Actually, this content will be actually provided by the vector database. I think this size will be so smaller for you, I think so, but it has given output like, hello, according to the content you have provided, the current metro area population in Delhi 2024 is some 33 crores, I think. I'm not sure, but it is the number over there, which we are seeing over here, right? Basically, it is able to understand the whole content which we have provided and able to extract the exact answer for the user's query. This is a simple, RAG which I have itself implemented. This retrieval of this area, right, content, right? Here only the vector database comes in, embedding model comes in, everything comes in to retrieve this content. Basically, for instead of that, I have provided the content over here so that it is able to answer. This is a simple example. I think all are able to do this, I think so. Able to communicate with the LLMs. Nice. Once. Yes. Oh, RAG models. Yes, vector database output, actually. Output. No, that is not exactly. Here we have said answer only based on the content provided, actually. Our prompt is over here. We can set up external libraries for putting guardrails over this. If the content is not, if the question is not related to the content also, we can block it. Now I have, for a simple use case, I have set up the guardrail as a prompt over here, actually. Now itself it can able to, sometimes it will be able to answer the question which is not related to the content also, but we have strict guardrails so that it will only answer to the content which is provided, or the company which is providing a guardrail over that. Only within this the LLM should answer. Within, related to only about our company only it should answer, means we can set it like that also. Hmm. Hmm. Okay. Okay. Okay, maybe he's asking like, we are downloading the model from Llama, which is Meta's, and we are using OpenAI's a library over here. How it is related? He's asking. This OpenAI library we are using to use the Llama model as a API endpoint, actually, over here. Only for API endpoint we are using OpenAPI here, because this will be more useful for developers in development environment. We can use like this. When it comes to actual production level open API key, we are just buying. We need to change only the API key and base URL and the model's name, actually, so that it will be just a few changes. These three things can, which will be given in the config file when we are moving to production level. So by changing this, only this model name and endpoint, if we are changing, we can change. We can use n number of models. So only we are using open API endpoint. API endpoint, yes. Anything. OpenAI's model endpoint also we can use, or any local endpoint also we can use over here. Yes, yes, correct. Yes, please. This, right? This is called prompt template. This one, this context, right? Context. We'll calling it as context for the which will be retrieved from the vector database. That is only you're asking. This is the Delhi's information you are asking. What is that? It is a context. Yes. Yes. Creativity, yes. Uh, Not like that. Even though if you are saying setting it as 0, right? How will it know we need to only answer from the context? It will be answering if we okay. Sometimes if we ask a question in ChatGPT and again ask the same question, it will be giving somewhat a different answer from the initial. Maybe the crux of the information will be the same, but the format it is saying, right, that will be different for each and every time. So when we are setting it to 0, that will be like same type of output mostly, not exactly the same words will be coming or the same answer will be repeating again. It is most same similar answers will be given for the same question. Output area, yes. But what the LLM should do should be, clearly defined in the prompt actually. Yes. Do you have any other questions? Still no? Yes. Yes.
JavaScript language.
Uh,
So like if I am or use Python is more.
Python is more recommended for building this RAG system or AI models, everything.
If you are doing for any Java.
Maybe some libraries will not be present, which is present in Python. Sometimes still there are some, we are using the endpoint using OpenAI, right? OpenAI also supports if this is Python endpoint code version. We have for JavaScript or any other versions also. Yes, yes. If we have the particular, if we are able to extract the text using any other JavaScript libraries, I'm not sure, but JavaScript things, that also will be possible. Not much, not much. The major time-consuming area is LLM over here. So LLM, wherever, however, I mean, any language you use, you are going to at the end call the model. So the model, the inference time for the, it must take that much time. Yes, thank you. Okay, I think let's get into the implementation of RAG. Once this LLM is ready, right, we can move the RAG. Basically, we are using PyPDF2 to extract the text from the PDF file. You can insert your PDF file path over here so that it will be extracting from each and every page. It will be extracted as a list. We can see the live example also. I'm just giving the 12th computer science book over here. Be sure with your path what you're giving and what you're storing actually. That is main important. Maybe it will cause lots of error. Once we install the PyPDF2, right, we will be able to execute and extract the all the pages from 12th computer science book. I think approximately it has 365 pages actually. I'll show you this also. Okay, basically what it is doing here is extracting the text from the PDF and storing it as a extracted text.txt file actually. We can see the txt file over here which is created now. This is the whole content of the 12th computer science book I have just uploaded. And this is the whole, this contains around 10,361 lines, maybe 10,360 lines. Once that file is ready, right, we use Langchain text splitter. This much time, actually, one second. In this slide, right, we have seen we used PyPDF to load actually from PDF file. We are using PyPDF to extract the text and store it as extracted text.txt file. That is the load thing what we did. The second thing split is now what we are going to see. We are using Langchain text splitter actually. We can see over here Langchain text splitter where it will load the text from extracted text.txt file. Then the chunk size is 1000 we have set it here. I think so. Some people were asking like, what is chunk size? Here is the chunk size. After the 1000 characters getting completed, it will directly chunk actually. It will stop over there. Then that row is getting completed. The next row starts actually. Then for that chunk, for the 1000 character, we will be creating the embedding model. That will be happening. Chunk overlap is something like if abruptly it is getting cutted, I mean, maybe it will be between a word or between a sentence, anywhere it can be. So chunk overlap is if we set here 200, right? Last 200 characters will be common to the chunk 1 and chunk 2. The chunk 2's last 200 characters and chunk 3 first 200 characters will be similar. So that once it is retrieving the 2 or 3 chunks, it could be able to relate easily. That's why we are using chunk overlap also over here. I think now you can understand and relate more. What we did here, right? Like here I have not used chunk overlap, but chunking is something after getting 1000 characters, we will just chunk as one part and the second part will be a new chunk. Chunk overlap is the last line of the chunk 1 and the chunk 2 will be more similar, I mean similar, exactly similar, to relate the relationship between the two chunks. That is why chunk overlap is there. I will execute this. I think you can see the whole whole text file has splitted into chunks actually. If we want to see the length, right? Okay, the whole 10,360 lines are converted into 650, I mean 57 chunks actually. It is chunk. There are each chunk will be containing 800, I mean 1000 characters and 200 overlap characters. So it is around 657 chunks actually. This chunk, each and every 667 chunk will be passed to an embedding model. Then it will be creating an embedding vector. Okay. Here we are using ChromaDB, right? Here we have actually we have not skipped exactly. We are not seeing the code level of embedding over here. We have seen how to load, we have seen how to split our chunk. The exact thing what is happening in embedding, right? Splitting into, I mean the splitter chunks are converted into vector, right? That is taken here by the ChromaDB actually. ChromaDB is none other than a vector database, which is our most popular database also, where we can pass the, we can create a collection name and pass the chunk over there. It will automatically convert it into vectors and store it. The advantage of this is like we need not to be worried about what is the embedding model we are using. If it change the version, what we are going to do, that and all we are not going to be worried because it is taken by the ChromaDB. Right? So the only duty is for us to pass the documents in the vector database and create an ID for that actually. Here I have created a 1, 2, 3, 4 ID up to 565. I mean, sorry, 657 chunks actually. Only duty is to, we need to pass, I mean, okay, we are importing the ChromaDB, then we are creating a collection name for that. It is like a table name we can exactly say for here compared to SQL. Then after creating a collection, right, we need to collection.add is equal to document is equal to vector database. Here vector database contains all the chunks in a list so that it can iterate by itself. After that, we need to give only one thing is the 657 IDs over here. What is a unique ID for that? This ID is not at all related to the embedding what is getting created. It is just only the ID. Embeddings are automatically created by the ChromaDB actually. That is the main thing over here. Let's just run. I'm creating a collection name called rag also. It takes some time. We can see that it is getting loaded. Each and every chunk is getting converted into embedding, and the embeddings are converted into, embeddings are passed to the stored in the vector database in the ChromaDB. I mean, it takes some time because there is a large context around 10,360 lines or 657 chunks. We can now everything is stored in the collection actually. To retrieve the questions over, right? We can like see, we need to, if we write a question over here, then again it will go to collection.query actually. Collection.query will do, automatically by internally it converts the question into embedding. Then the embedding will be getting searched in the vector database and give us top relevant chunks. Here the n results is equal to 8, right? I have set it here, we have 657 chunks. I'm taking the top 8 relevant chunks related to the questions. What are the top 8 relevant chunks which is more related, or the distance between the question and the chunk, which is has a very less amount, right? I'm retrieving that alone. We will see a demo also. Okay. I have just asked a question like, who is the founder of Python? Maybe like next, it is that question is passed to collection.query, which is exactly asking to the vector databases. Then it will be returning us the top 8 results. We can see 1, 2, 3, 4, 5, 6, 7, 8. 8 results are over here. Within this, it will be the answer may, or I mean mostly within this, in any chunk, the founder of Python will be present. Once this, maybe the human can't read this full content or understand, so that only we are calling LLM over here, so that like if you pass this question, which is passed, who is the founder of Python, and the vector database answer, VDB, vector database answer to the LLM, right? Now it could be able to do more easily. Actually, it is generating. Meanwhile, I think it is generating over here. We can see in this application also, it is actually generating the answer. Okay. From that context, we can easily able to txt interaction between this all actually the whole format of the LLM, like interaction between these are all customizable using prompt. Once the chatbot answer, okay, I think you can see this. This was the answer actually generated by the LLM. This is interaction between the customer, the chatbot, the customer asking the question. This is the question what we passed, and the chatbot is saying the answer. Actually, the founder of Python is Gladio, and he created a Python in 1991. Actually, these information are passed in the context, and the question is also passed, so it is able to answer more easily. That is why we have initiated the LLM over here on the RAG system. Everything is, instead of you can upload any PDF now also. From here, you can just upload the PDF, convert it into text files, save that in the ChromaDB or vector database. This is one of the ChromaDB where I mentioned there are a number of ChromaDBs. After using this ChromaDB, right, you can ask this query to the ChromaDB. It will retrieve the answers. That answers will be passed to the LLM, like the user's query and the vector database answer. Then the text will be like the answer of the exact question. Here, the last part comes with the Bhashini translate. Like we are converting the English to the Hindi users you are using your application. Once we pass the text, it will be giving us the answer out in Hindi format. The same question. So it becomes a multilingual RAG chatbot. Okay, let's complete the last slides what we are having. Actually, this is a major difference between actually fine tuning and RAG. Both will be having the base LLM. The same. Actually, we are also having the Llama 2 as the base LLM here. But when it comes to fine tuning, right, you need to have the custom data, custom training code, and everything. The use case what you have, you need to train the model actually. It is like building your own AI model. This fine tuning is actually. This is fine tuned, and you will get the similar results. If you want to insert your company's knowledge, right, you can use fine tuning method also, but that will be not that much efficient also. It will be able to pick up your company's ideas and your company's policies and all. But still, when it comes to RAG, right, it is a very simple thing. Like PDF, we can convert it into and make it as your own company's chatbot, which will be answering your own company's alone, because we are using the vector database and embeddings now and retrieving the answers what is related, and that is actually RAG over here. So we can achieve the same results by 2 methods, but the most easy and efficient method will be a RAG method. Maybe it will be like a costlier method, which is a time-consuming method also. So only we choose RAG, and we are doing this. Actually, you can try out any of the PDF you have currently also. And end of the day, now we have built a very simple RAG system, very simple RAG system, where we are having some data. We are inserting the data into the database format. We are retrieving it and using an LLM to answer. But when it comes to advanced RAG, right, there are lots of content. Content needed to be understandable, because when it comes to PDFs, right, We need, it is not a simple PDF alone. The PDF may be containing a table. The PDF or any file may be containing some image also. The image, inside that image there will be text. Or anything, once we have uploaded a PDF, it will not be able to extract the exact text. But we need to handle the PDF in the way that we need to understand the table, images, everything, so that it will be more easy and efficient for LLMs or to getting stored or getting retrieved. That will be more easy and efficient way. That is where I have given the format understanding here, because it may be like when it comes to images which is containing the text also, we need to handle, right? So I have mentioned, like already I mentioned, guardrails are the things which I have already mentioned. Like it must, the LLM at the point, the end user point of view, right? He's chatting with a chatbot. So we are the people who are responsible, so that the user can ask n number of questions, any type, anything. But we are the people who are responsible for putting a guardrail or putting a rules mechanism to the LLMs. You must be answering only to specific questions like this. That are the things comes under guardrails. There are n number of chunking strategies. Now we have used 1000 character default chunking strategy, or which is a fixed number of length. But when it comes to chunking itself, a large large topic actually. There are a number of chunking strategies like semantic chunking. Semantic chunking means understanding the context actually present in that whole text file, and after that it will chunk. It will not exactly chunk at the 1000th character. And there are like semantic chunking and some other chunking methods, topic wise chunking. If we are uploading a book, if we are interacting with a book, right, book will be having chapters will be having subheadings will be having subtopics. Like that we can chunk over like that also, chapter wise, inside a chapter, particular topic wise also we can chunk. That's all chunking strategy. When it comes to embedding model, right, now today we have currently seen ChromaDB's embedding model, which is defaultly present. We didn't get that much hands-on on embedding model. But when it comes to embedding model, creating a domain-specific embedding model, creating may be somewhat harder point. Again, it will comes under training, data set training, costs and all will be involved. But when it comes to domain-specific embedding model, which is there, open source embedding models will also be available. So that if we take up, as I already mentioned, if we are chunking healthcare domain related data, right? So if we use the embedding model later to, which is trained on healthcare domain, then it will be easy and efficient way for it be storing and retrieving. So that is domain specific embedding. High efficient vector DBs are now we are currently using ChromaDB. ChromaDB, there are popular ways to extract that information. Currently we are using cosine similarity to find the difference between 2 points. Actually there are more ways for finding distance between the 2 points also. So each and every vector database will be having different types of strategies for retrieving the similar content which is inside the SQL. So that differs. Choosing that efficiently is another task. Then comes the prompting techniques. Prompting techniques are also like very important over here, because we need to set what is the duty of the LLM, what is the rules for the LLM, what is the exact task for the LLM, where it is actually deployed, or what is its duty. If you are the LLM which is deployed in the company's front page chatbot will be different. The chatbot which after a user logins and getting chatted should be different, because after the user logins your application, right, he must the chatbot should be able to understand who is the user, what is his background, what is his history records. But the chatbot which is present in the outside before getting login, it must be only able to answer the generic information of the company. So there the location of the chatbot itself very important. Efficient LLM, when it comes to using efficient LLMs, right, we currently use Llama 2 LLMs. Llama 2 LLM, Llama 2 7B LLM. There are 13B LLM, 70 billion parameters LLM. That are all, each and everything will be getting increased by its accuracy. But you can also say that we are only providing the content, then why accuracy is needed. But still that time also we need to consider what is the context length of the LLMs. So that if for a RAG system and all, we need to have a high context, token length. so that it will be able to process a large text actually. If a chunk is giving out 10,000 characters, right, then it must be able to understand the 10,000 characters. This is the context, this is the question, so we must answer within this. So LLMs also play a major role here. Exception handling or something, as I already said, what if the user's query and the chunk which is retrieved is not at all related? How should the LLM, the chatbot should behave? Or if you don't have any answers or any, within this there are lots of moving parts which I showed this time in RAG system. Any one is getting failed, what should we do? So we need to handle that also. The last part comes with the RAG evaluation. In these days, evaluating the GenAI applications are getting so hard. But still, when it comes to, we need to prove that using RAG is a more efficient method or it is a very good method, then we need to prove that in an evaluation matrix. How we are going to do that? That are all comes under the techniques or advanced RAG concepts. So building a simple RAG application is also easy, and we need to also consider when it getting into production, we need to consider all these things, and only we need to move to production level.
Hello. Yeah. Hope like the session was useful today. And how many of you know Tech for Good? Like, okay. For those of you who do not know, so Tech for Good is an initiative which GDG Coimbatore started last year. So GDG Coimbatore has been running all this sort of events, conferences for the last 10 years. And something like that we observed and realized is that, so most of the time, whenever any new technology that comes out, right, we do one day event like this, maybe half a day, etc. And then we look at it, and then if you're not working on those technologies, you do not put that into practice. And most of the time, any coding or anything, right, like unless and until you practice, execute it, like get bugs, solve it, debug it, you'll not be able to learn it, right? It's like riding the cycle for the first time. So like what we thought is like we started doing this thing called Tech for Good. It's a hackathon. 1 month or like we will have like a lot of workshops where people come and learn something, and then at the end they can put all their learnings into something actionable. So இன்னொன்று வந்துட்டு like everybody understands Tamil, right? Okay, cool. அதாவது மற்ற ஹேக்கத்தான் மாதிரி இது வந்து போட்டிக்காக பண்ற ஹேக்கத்தான் கிடையாது. இட்ஸ் அபவுட் லைக் லேர்னிங் டுகெதர்க்காக பண்றது. ஸோ ஹவு மெனி ஆஃப் யூ லைக் வேர் பார்ட் ஆஃப் லாஸ்ட் இயர்ஸ் டெக் ஃபார் குட்? ஓகே, கூல். ஸோ உங்களுக்கு ஃபீட்பேக் வேணும்னா நீங்கள் அவங்ககிட்ட கேட்டு பார்க்கலாம் எப்படி இருந்துச்சுன்னு சொல்லிட்டு. ஸோ என்னன்னா இன்னொன்று வந்துட்டு இங்கே இருக்க ப்ராப்ளம் ஸ்டேட்மெண்ட்ஸ் எல்லாமே வந்து பார்த்தீங்கன்னா இட்ஸ் சம்திங் ஃபார் த சோஷியல் காஸ்க்கோ குட்டுக்கோ இருக்க மாதிரி. ஸோ ஒன் வி ஆல் ஃபீல் டு கெட் ஒரு விஷயத்த பண்ணும்போது வி ஃபீல் கனெக்டட், ரைட்? இதுவே இல்லாமல் வேற ஒரு ஐடியா உங்களுக்கு அதுக்கு ரிலேட்டடே பண்ண முடியாமல் இருந்துச்சுன்னா you will not be able to passionately work on something. So on the basis now, so last year we collaborated with Coimbatore Corporation, Coimbatore Police Department, and then we collected problem statements. So adhe mari in the varsham vandittu we have collected problem statements from NGOs. So adula da in the data model in the library ellame avanga kitta irundhu vandadha. So ipo Bhashini nu one irukku, adukaprom sign language model irukku. Idha vechittu engalukku idukku mela build panni kudukka mudiyuma nu solittu. So again it is an experiment. நம்ம அதாவது இது பண்ணிட்டு நீங்கள் ஒரு 100% கம்ப்ளீட்டாக பண்ணி கொடுக்கணுன்ற அவசியம் கிடையாது. நம்ம பண்ணுறதை வச்சுட்டு இட்ஸ் சார்ட் ஆஃப் கிவிங் அ தாட் ப்ராசஸ் ஃபார் தெம். ஸோ அதுக்கு மேலே இருந்துச்சுன்னா வி குட் கிரியேட் இட் அஸ் ஓப்பன் சோர்ஸ் ஒரு டூலாவோ இல்லை ஒரு ப்ராடக்டாவோ பண்ணி வி கேன் ஒர்க் அலாங் வித் என்ஜிஓஸ் அண்ட் தென் வி குட் பில்ட் ஃபர்தர் அஸ் அ கம்யூனிட்டி. So there are like totally 4 problem statements. So t4g.gdgcbe.com and the problem statements are there. Again, like today, the whole workshop was based upon like one of the problem statements there. If you are interested in working on anything, and for example, if you are a professional who can like support students, you can sort of reach out to us and then say like in the problem statement la na work pannalan irukken. So I could connect you with like other students or somebody who also interested in that. So you can all form as a team and then you can work together. ஸோ இது வந்துட்டு நான் காலேஜ் என் ஃப்ரெண்ட்ஸ் இது வந்து போட்டி கிடையாது. நான் திருப்பி அதுதான் சொல்கிறேன். இட்ஸ் அபவுட் லைக் கொலாபரேட்டிவ்லி ஹவு வி கேன் ஒர்க் டுகெதர். ஸோ யூ வில் ஆல்சோ பி ஏபிள் டு லைக் கிராஸ் லேர்ன் ஃப்ரம் ஈச் அதர். இப்போ ஸ்டூடெண்ட்ஸ் வந்து ப்ரொஃபஷனல்ஸ் இருந்து கற்றுக்கலாம், ஒரு காலேஜ் பசங்க இன்னொரு காலேஜ் பசங்கிட்ட இருந்து கற்றுக்கலாம். மேபி நீங்கள் கம்ப்யூட்டர் சயின்ஸ் படிக்கலாம், இன்னொருத்தங்க வந்து வேறு டிபார்ட்மெண்ட்லேருந்து இருக்கலாம். ஸோ இட் இஸ் அபவுட் லேர்னிங் டுகெதர் தான். ஸோ again like we will also be doing further workshops as we go on like on other things also. So இதோட பேரண்ட் ஈவெண்ட் ஒன்று இருந்திருக்கும், நீங்கள் ரெஜிஸ்டர் பண்ணும்போது பார்த்துருப்பீங்க. நான் அங்கே வந்துட்டு போடுவேன். அது இல்லாமல் ஜென்ரலாகவும் இந்த ஒர்க் ஷாப்ஸ்க்கு தனியாகவும் ஈவெண்ட்டும் நான் கிரியேட் பண்ணுறேன். ஒன் ரெக்வஸ்ட் இஸ் லைக் வி வில் பி ஆல்சோ லைக் ஓப்பனிங் லாஸ்ட் டைம் நம்ம பண்ண மாதிரி கூகுள் ஃபார்ம்ஸும் ரிலீஸ் பண்ணுவோம். யார் யார் என்னென்ன ப்ராப்ளம் ஸ்டேட்மெண்ட்டில் இன்ட்ரெஸ்டடாக இருக்கீங்கன்னு சொல்லிட்டு I'll create you all as a group so that you can all work together. So last time பார்த்தீங்கன்னா நிறையா ஸ்டேட்மெண்ட்ஸ் இருந்துச்சு, கொஞ்சம் பிச்சு போன மாதிரி இருந்துச்சு. ஸோ அதனால இந்த வாட்டி 4 ப்ராப்ளம் ஸ்டேட்மெண்ட். So we can form like 4 core teams and then people based upon their interest can work on like each of it and sort. And one request, like if you're a professional and then you can sort of lead one of the problem statements, like do reach out to me so that I will connect like other students and people who are interested, so you can lead that effort also. Okay, any other questions? And Srijat like told like he's available online, any platform. If you reach him, he said like he will help you all if you have any doubts or questions. And also you can reach out to me, like I will connect you with any of the speakers also. Okay, yeah, that's all from my end. If you have any other questions, you know, like you can drop an email to gdgcb@gmail.com, or you can reach out to me on any social media, like I will be able to respond. And thanks for coming. And yeah, that's all from there. If you have any questions, you can ask him, or if you want to network, we can then wrap the event. Thank you.